Good morning. I am Dr. Kumarasamy. I am going to explain about mesh method. Right? In the circuit theory or B.E, there are so many methods. A mesh method or nodal method or some of the theorem used to find out current flows through the any components in the circuit. By using this theorem or by using the mesh method or nodal method, we can determine the current flows through any components in the circuit, right? Here for sample, I am going to share one circuit. Right. Here I am sharing one circuit. By applying the mesh method, we are going to find out the current flows through the various mesh here, right? In the given circuit, first, what is mesh? That is on closed path. That is called what here? Mesh. One closed path in the circuit, right? Here, let us consider this one of the closed path and this one second one and this one. There are three closed paths are there, right? Closed loop. Closed loops are called here mesh. We are going to find out the current flows through the various mesh. Okay. Once you know the current flows through the various mesh, then we can determine current flows through any component in the given circuit. For example, if they are asking determine the current flows through the 1 ohm resistor. If you know the mesh current flows through the first mesh and second mesh, then difference between these two will flow through the 1 ohm resistor, right? Here, first I am explain how to find out the various mesh current, right? Whenever you are going to apply mesh method, the first step is you assume mesh currents, right? Generally, they will give circuits only. They will give, for example, 7-volt battery, 1 ohm, other side 2 ohm, here 6-volt battery, 2 ohm, 1 ohm. Only the circuit, they will give in the question, they will give the circuit. First step, you have to assume the mesh current. That is what? Step 1. Assume the mesh current. Here I assumed the mesh currents in the first mesh. First mesh current I1. Here I am considering first mesh current I1. The direction is clockwise direction. I am considering the current flows in the clockwise direction. This one is mesh 2. Here I assumed the current flows through the mesh 2 is I2. Current flows through the mesh 2 is I2. And then this one is mesh 3. Current flows through the mesh 3 is I3. Here I assumed there are three meshes are there. I assumed three mesh currents, I1, I2, and third one is I3. Okay, this is what first step. And second step, you have to apply the KVL, Kirchoff voltage law, right? By applying the KVL, we can form the equation for each mesh, right? Here, how to form the equation for each mesh means, let us consider the KVL. While consider the KVL, we can give, there are two statements in the KVL. One is sum of potential rises, that is equal to sum of potential drop in the closed loop, right? We can write the equation in such a way that we can group all the sum of potential rises in one side, another side, that is equal to all the drops, rises equal to drops. That is one idea. And another statement is the algebraic sum of voltage in a closed circuit is equal to 0. The algebraic sum of voltages, algebraic, that is with the sign if you are consider. For example, give positive sign for potential rises and negative sign for drops. That is finally if you are adding both, that is equal to 0. As per this statement, for example, First statement, potential rises equal to drop means 7 volt. That is equal to all the drop. If you are adding, we can get 7 volt. Another one, second statement, I said algebraic sum of voltage, algebraic sum of voltage around the closed path is equal to 0. So as per the second statement here, for example, 7 volt algebraic sum plus 7, then minus 5, then minus 2. For example, minus 5 volt dropped here and 2 volt dropped across the 2 ohm resistor means, then I can write plus 7 minus 5 minus 2 equal to 0. That is what we can form the equation by using statement 2. Here I am using the second statement, algebraic sum of voltage around a closed path is equal to 0. By using the statement, we are going to form the equation. For that, how to write the equation? First, algebraic sum means we should give the sign for each of the drop. I said for rises, plus sign, drop mean negative sign. How to find out? For example, in case of DC circuit, only resistance are there. You no need to analyze anything. Just if you see any resistance, just you give minus sign, then you write the equation. For example, here 1 ohm resistor is there. First you write minus 1. Then what is the current flows through that? Then you can analyze. Then you can write the what are the currents are flowing. Then you can write that equation according to the direction of flow. Right. Here I am first telling about only the assigning of sign. Just you put negative sign for all the resistive drop simply. Then positive sign for rises. But here, while you considering the battery, we should analyze whether the battery is charged or whether the battery is supplied. Based on that, you can do the sign. Resistance means there is no need to analyze anything. Just blindly you can give negative sign for resistance. But for battery, we need to consider. For example, the 7 volt battery. How can I know whether it is supplied or get charged? Get charged means it is considered as the load. We should give negative sign for that. How to find out? That is by using our assumed current direction. We only assumed this current direction, mesh current direction, I1. This is the assumed mesh current direction here. I assumed in the clockwise direction. Okay. In the clockwise direction, I am assuming the mesh current. As per assumption, now from the positive terminal inside the battery, there is no current flow. Just you consider always current flow from the one terminal to another terminal, not inside the battery. Minus to plus or plus to minus inside the battery, you should not consider here. Right? You should consider always terminal to next terminal through the element. Here, let us start with the positive terminal. Here, current started with the positive terminal as per our assumption. Current started from the positive terminal, then it will flow through the 1 ohm resistor or another direction, then finally 2 ohm resistor, and here finally it will reach the negative terminal. So if the current is flows from positive terminal to negative terminal, if the current is flows from positive terminal to negative terminal, we should give plus sign for that battery. Otherwise, if the current is flows from negative to positive, means you should give negative sign for that. Okay. Now let us see how to form the equation. For example, in the mesh 1. Okay. In the mesh 1, first I am started from the 1 ohm resistor. I am going to form the equation. For that, I am first consider 1 ohm resistor. What are the current flows through the 1 ohm resistor? In the normal Kirchoff law, if you are applying only one branch current, just we are considered current flows through the 1 ohm resistor where it is upward or downward direction. But in the mesh method, the advantage is we can assume there are more than one mesh current can flow through the each of the resistor. There is a possibility more than one current can flow through the resistor. Here, I1 is flowing in the downward direction as per the assumption. I1 is flows through the downward direction. That is current flows through the 1 ohm resistor. Another one is I2. This one is I2 here, right? In the diagram, right? I2 also flowing through the 1 ohm resistor, but as per the assumption, clockwise direction. Okay. Now the current is flows in the upward direction through the 1 ohm resistor. So I1 is flowing in the downward direction, I2 is upward direction. If they are flowing in the opposite direction, means you have to subtract the current always. I1 minus I2. Since you are writing the equation with respect to mesh 1, so you subtract whatever the current flows in the opposite direction of I1. So I2 flows in the opposite direction. First I said sign is negative. Since it is resistor, blindly you can give negative sign, minus 1 ohm resistor. So minus 1, then about the current, 1 into some drop, V equal to I into R. R, I am writing 1 ohm into R, I into R, right? R value is 1 ohm. Now I value is unknown value. That current flow, I value means current value. Current flows through the 1 ohm resistor is, I said I1 minus I2. Since I am writing the equation with respect to mesh 1, I am subtracting the voltage drop due to other current. Other current is here I2. So I1 minus I2. I1 minus I2. That is 1 ohm resistor. And next one is what? One battery source is there. I said while you assign the sign for the battery, we should consider where it is plus or minus. Okay, resistor means blindly minus. Battery means we should consider about the current direction. As per things, no current can flow inside the battery. As per the assumed direction of current, 1 minute. Here, as per the assumption, current will flows this direction, then here, then here, then closed like this. Okay, that is what here I said current is flows in the clockwise direction. Okay. Now, as per the assumption here, inside the battery there is no current. If you are consider, current is started from minus, then it is flowing, then flowing like this direction, and ended with the plus. Entered in the positive terminal. Current leaving from the negative terminal and entered towards the positive terminal. So current is started from negative terminal and then entered into the positive terminal. If the current is supplied from the negative terminal entered to the positive terminal, means now the battery is charged. It is considered as the load. So you give negative sign for this one. This is not potential rises. As per my assumption, this is a potential drop. I am considering minus 6. Suppose my assumption is wrong, means the final answer, if you are getting any minus 6 ampere or minus 2 ampere, then we can assume the current will opposite to the assumed direction. That is finally we can decide where assumption is wrong or not. First you assume the direction of current and determine as per the assumption. And finally your sign will indicate whether your assumption is right or wrong. Right. Suppose if you are getting negative answer, then there is nothing to worry. Just you write, for example, instead of minus 6 ampere in the downward direction, we can write plus 6 ampere flows in the upward direction. Like that, we can give the final answer. You no need to worry about that. Okay. Just as per the assumption, here I said battery is what? Charged here. We are consider that one is minus 6 ampere. Sorry, minus 6 volt. Okay. Then next one is resistor again. Here I am started with the point here. I am going to form the equation from this point. 1 ohm resistor over, then 6 volt battery over, and next one is 2 ohm resistor. You blindly give, since it is resistor, -2. So -2 into, then current flows through the 2 ohm resistor. What are the current flows through the 2 ohm resistor? I1 in the downward direction, I3 is in upward direction. So I1 minus I3. Suppose both currents are flowing in the same direction, means you put I1 plus I3 here. If they are in opposite direction, you subtract from I1. Since you are writing from the from the mesh 1, you are forming the equation for mesh 1. So always you subtract from I1. If they are in opposite direction, both are in same direction means plus. Okay, opposite direction. So I1 minus I3. Now 2 ohm resistor over. In the next branch, there is no element. In the next branch, 7 volt battery is there. I already said, now the current is flows from positive terminal to negative terminal. So here plus 7. This one is what? Plus 7. That is equal to 0. Then just you rearrange the equation. One minute. Just you rearrange the equation before. To solve the equation mathematically, first you write the equation, then you multiply -1 into I1, then -1 into I2. So -1 I1 minus plus I2, -6 -2 into I1 -2 I1 -2 into -I3 +2 I3 +7 equal to 0. Then you add all the I1 into one side. You add all the I1, then you add all the I2, then I3. Right. First minus I1, here -2 I1. So totally -3 I1. Like that, you have to add all the I1 into one side. So -3 I1, then +2 I2. Only if you are adding all the I2, we can get plus I2, plus I2, then +2 I3. That is equal to, here I'm rearranging. One, we are getting +7. If you are taking the +7 into other side, we can get -7 in the above equation, and one -6 we are getting, then it will become +6 in the right hand side. So -7 +6, so -1. Then you multiply by using a negative sign, we can get 3I1 minus I2 minus 2I3 equal to 1. Just I'm multiplying by one negative sign. First mesh over. In the second mesh, I'm going to write the equation for second mesh. Again, I will show the same diagram. In the second mesh, this one is second mesh. Let us start from the 2. Start from the 2. Now 2 into second mesh current, I2 only flowing through this. -2. Always, whenever you find out any resistance means, you put minus sign. So -2 into I2. -2 into I2. The equation here I'm writing. -2 into I2. And next resistor, -3. Whenever resistor is there, blindly you put minus sign. Then you write about the current. -3 into, what are the current flows through the 3 ohm resistor? One current is I2. I2 flowing. Another current is I3. As per the assumed direction, I3 is flowing from left to right. I2 is right to left, opposite. So I2 minus I3. Since you are writing the equation with respect to mesh 2, you subtract all the current from I2. So I2 minus I3. -3 into I2 minus I3. That is what this one. Here in the mesh 2, I'm writing -3 into I2 minus I3. And next one is the next resistor, -1 ohm resistor. Let us see the diagram. Again, I will show the diagram here. 1 ohm resistor is there. So here -1 ohm into -1 into current flows through the 1 ohm resistor, what? I1 and I2. This time I'm writing the equation with respect to mesh 2. I need the voltage drop due to the second mesh. due to second mesh current. I into R I am going to write. R I am writing -1 into I is what? I2 minus I1. I need the drop due to I2. So subtract the drop due to I1. Only due to the I2, what is the drop? Just you write. So here -1 into I2 minus I1. This one is -1 into I2 minus I1. Then you rearrange the equation. Just you multiply -3 into I2, -3 into minus I3. So minus of minus plus 3I3. Then -1 into I2 minus I2. Then -1 into minus I1. So minus of minus plus I1. You add all the I1 here. Only one I1. So I1. Then you add all the I2 minus 2I2 minus 3I2. So totally what? Minus 5I2. Here one minus I2 minus 6I2 plus I3, only 3I3. That is equal to 0. Let us take second mesh equation, final equation 2. And third mesh, you apply the KVL for mesh 3. Here also, with the help of circuit, I am going to form the equation. First one is 1 ohm resistor. Let us start from here. The mesh 3, I am starting here. Right. Just you take from this point. Then 1 ohm resistor. Then there is no element. Then 2 ohm resistor. Then battery. Then 3 ohm resistor. And finally end with the same point. That is what one. Third mesh. -1 into current flows through this 1 ohm resistor is only I3. Okay. So 1 into here I3. So -1. Since it is resistor, just you put blindly -1. -1 into I3. That is what first one. -1 into I3 minus I3. And next resistor, 2 ohm resistor. Here 2 ohm resistor. This one is current flows through the 2 ohm resistors are I3 and I1. So -2 into, I said always resistor is there, put minus sign. -2 into, since I am writing the equation with respect to mesh 3. So I3 minus I1. So -2 into I3 minus I1. Then battery. Next one is battery. I give negative sign while we are forming the equation for mesh 1. But for the mesh 3, as per the assumed direction of I3 in the mesh 3 current, now you consider to give the sign for battery, you consider the current direction of I3. Don't consider the current direction of I1. Now you consider I3 current direction. I3 current is flows from positive terminal, 3 ohm resistor, 1 ohm resistor, 2 ohm resistor, the negative terminal. It will enter into the negative terminal. Started from positive terminal. So positive terminal is supplied the current as per the third mesh. So with respect to third mesh, is the potential rises. So Q +6 for this one. Resistor always get negative sign. Battery can get the sign with respect to whether the positive terminal is supplying the current or not. The positive terminal supplying the current means positive. Otherwise, if the negative terminal side is supplying the current means negative. Okay. Here +6. Then -3 next resistor. This resistor -3. Here I2 and I3 are flowing in the opposite direction. Okay. So here let us consider I3 -3 into I3 minus I2. Here -3. Why I am given -3? Since it is resistor, blindly I can give -3. So -3 into other two current, -3 into I3 minus I2. Since I am writing the equation with respect to mesh 3. So I3 minus I2, that is equal to 0. Okay. Now you group all the I1 into one side, I2 into one side, I3 into one side. Just mathematically, sorry. You group all the I1, I2, I3 here, right? -2 into I3 -2 into -I1. So +2 I1. here minus 2i3, then minus 3 into i3, minus 3i3, then minus 3 into i2, plus 3i2, minus 3, minus i2, minus of minus, plus. Rest of the things are minus i3. I'm considering the minus i3 as it is. This one is multiplied, and this equation also I multiplied. Then group all the i1. 2i1, 3i2, minus 6i3 plus 6 equal to 0. Then you take the 2i1 plus 3i2 minus 6i3 one side, plus 6. Other side, if you are bring the 6 volt into right hand side, means we can get minus 6. Then you multiply by a negative sign, we can get plus 6. This side we can get minus 2i1, minus 3i2, and then plus 6i3 equal to 6. This is the third equation. Now there are three unknown, I1, I2, I3. Three equation also, mesh 1, mesh 2, mesh 3. There are three meshes, so that we are forming three equation. Three unknowns are there. We can solve this equation by using some algebraic method. That is, for example, equation 2 minus 3, then equation 1 minus 3. In both time, you can subtract the I3 in such a way that you multiply by using some factor, subtract I3, you can get two equation, I1, I2. Thereafter, you make the I2 equal to 0. You can get the answer for I1, you substitute, you can get I2. Then if you are substituting I1 and I2, then we can get I3. That is what a normal algebraic equation solving method. I'm not going to explain that method now, so that I'm simply said, simply by using normal mathematics, three unknowns are there, we can solve it. That you know already, okay. But another one method is, by applying the grammar rule also, we can find out the answer. By applying the grammar method. For the grammar method, from the each of the equation, you take all the coefficient of I1, I2, I3. From the first equation, 3i1 minus i2 minus 2i3. Coefficient of i1 is 3. Coefficient of i2 is minus 1. Coefficient of i3 is minus 2. So 3 minus 1 minus 2. Just you write all the coefficient 3 minus 1 minus 2. From the second equation, just you write 1i1 minus 6i2 plus 3i3. So 1 minus 6, 3. Right. Then third equation, minus 2i1 minus 3i2 plus 6i3. Coefficient of I1 is minus 2. Coefficient of I2 is minus 3. Coefficient of I3 is plus 6. Just you write coefficient matrix into unknown value, I1, I2, I3. Unknown value, this I1, I2, I3 from all the equation, equal to right hand side. First equation equal to 1. Second equation equal to actually 0. And third equation is equal to, here we are getting 6. Just you form this. Now, by applying the grammar rule, we are going to solve this what matrix equation. For that, first you find out del value. Del equal to the coefficient matrix. Just you write the coefficient matrix, then you find out the determinant, that is 3 into, you know the rules, right? To find the determinant, 3 into, you just cross this row, sorry, this column and this row. Then 6 into 6, 36, plus into minus, so minus 36. Then as per the matrix rule, you put one minus sign. Minus of minus 3 into plus 3, minus 9. Minus of minus plus. So here plus 9. 3 into this one. Then minus of minus 1 into. So minus of minus plus 1. In the matrix, plus, then minus, then plus. We should give the sign like that. So minus of minus plus 1 here. Plus 1 into, just you cross this one, this column and this row. Remaining values are 1 into 6. 1 into 6. Then minus of minus 2 into 3. So plus 6. Then similarly, minus 2 into this one. Minus 2 into, you cross this row and this column. We can get minus 3 into 1. So minus 3 minus 2 into what here third row and third column is we are cancelling third row and third column. So minus 3 into 1 minus 3, then minus 6 into minus 2, actually plus 12, then you add one minus. That is what rule of matrix, right? So minus of minus 2 into minus 6, so minus 12. So you find out this value 36 minus 36 plus 9 minus 27, 6 plus 6, 12 into 1 12, then 12 plus 3 minus 15 into minus 2 plus 30, and finally we are getting what? Minus 39. That is what del value. Let us find, next one is to find the I1 value, we need del 1. Actually del 1 by del equal to I1, or I can write del I1 by del. Del will get cancelled, we can get I1, right? We can represent by del 1 or del I1, whatever may be. Okay, now to find the del 1, how to find the del 1 means, in the given matrix, this matrix or this matrix, in the given matrix, you replace the first column. You replace 3, 1 and minus 2. This one is what? First column, right? Just you replace this first column by the value of voltages, this value 106, right? Just you replace 3, 1 minus 2 by 106. Then you will get one matrix. Find the determinant of that one. That will give the delta 1. Okay. Now, I said del 1 value. Del 1 value equal to, first column I am replacing 106. Rest of the values are similar, same values. Again, just you find out same thing. 1 into here 6 into 6 minus 36, minus of minus 3 into plus 3, minus of minus plus, so plus 9, plus minus of minus here plus 1 into, if you are crossing this one and this one, 6 into 0 6, then minus of 6 into plus 3 minus 18, then minus 2 into this row and this column cancel, 0 into 3 6 into 6, so minus of minus 6 into 6, so plus 36. You can get minus 117. That is del 1. Similarly, del 2. Del 2, second column, this one, second column is replaced by 106. Rest of the value we are keep as it is. Here 106. This 106 replaced in the second column, minus 1, minus 6, minus 3. The second column replaced by this 106 for del 2. For del 3 means third column should be replaced by 106. So here del 2, second column replaced by this value 106. Then you find out the determinant minus 78. Then del 3, third column replaced by replacing the third column again by normal matrix rule. You find out del 3 value 3 into this one, 3 into 6 into 6 minus 36 minus 3 into 0 0. Like that you find out, you can get minus 117. Then I1 value equal to, hereafter I1 value. I1 value equal to del 1 by del. I1 equal to del 1 by del, that is equal to minus 117 del 1 value divided by del value minus 39, 3 ampere. Actually, sometime we will denote this del 1 is del I1. Easily you can remember, del get cancelled, we can get I1 like that. So some of the book they will denote this not del 1, del I1. This one is del 2 or del I2. So I2 equal to del 2 by del minus 78 by minus 39. Del value common, minus 39 always. I2, I3 value, del 1, del 2, del 3 value. We are replacing the first column, we are find out this one. By replacing the second column, we are find out this one. And by replacing the third column by using voltage value, we are find out what del 3. That you substitute here, we can find out various mesh current I1, I2, I3. Okay, this what mesh currents. In this problem, just I find out only the mesh current I1, I2, I3. In the in some other problem, if they are asking, for example, what is the current flows through the 1 ohm resistor, means here I1 minus I2. What is the I1 and I2? Let us find I1 minus I2. 3 ampere minus 2 ampere. 1 ampere flows in the direction of current I1. What is the direction of current? 3 minus 2. I1 is 3 and I2 is 2 ampere. So through the 1 ohm resistor, 3 minus 2, 1 ampere. 3 minus 2, 1. 1 ampere is flows in the downward direction. So our assumed direction is correct here. Okay. Like that, we can find out current flows through the various resistors. For example, current flows through the 2 ohm resistor is what? The value of I2. Only I2 can flow through the 2 ohm resistor. So 2 ampere is flows through the 2 ohm resistor. That is the current flow. If they are asking the what is the voltage drop across the 2 ohm resistor, means current flows through the 2 ohm resistor is I2, 2 ampere. Resistance is 2 ohm. So 2 into 2, 4 volt. Voltage drop is 4 volt. Sometimes what is the power dissipated in the 2 ohm resistor, means we can write I squared R formula. I is what? 2 ampere. 2 squared into R, 2 ohm. So 2 squared is 4 into 2, 8 watts. 8 watts is flows, here dissipated in the 2 ohm resistor in such a way that we can find out the current flows through the each of the element. We can find out the voltage across each of the element, and we can find out the power dissipated in the each of the element by using mesh method. Okay. Thank you.